Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are finishing up sign diagrams right now with part 2. Just a couple of examples. It should be quick. Let's get to it, shall we? All right. Thank you, Ms. Golding. Beautiful as always. So, now we're going to draw a sign diagram for 12 minus 3x squared. That is a quadratic, so we should know that's going to look like a parabola. So I'm going to set that equal to 0. I can factor out a 3, and I get 4 minus x squared equals to 0. So I set that equal to 0, or this factor 4 minus x squared equals 0. I get 4 equals x squared. Take the square root of both sides, plus or minus root 4 equals x. And so plus or minus 2 is equal to x. So again, those are my critical points. Those are if change is going to occur from positive to negative or negative to positive, it will happen when x is equal to plus or minus 2. So I'll go ahead and mark those. 2, negative 2, and again, there's my fave 0. So my first test point will be x equals 0. And I'm going to go ahead and use the original function. That's going to be the easiest part. And I'll just put that up here. The original function is 12 minus 3x squared. And with 0, it's very easy. 0 squared is 0 times 3 is 0. So I'm just left with a positive 12. So positive right there. Since it's a parabola, we really should be able to figure it out from here because we know it's opening down. So we should figure that it's negative on both sides, but let's just test it out. I'll go to the right of 2, and I will test x equals positive 3. And 12 minus 3x squared, I'll go ahead and work it out. You should be able to do it in your head, but just in case, that would be 12 minus 3 times 3 squared is 9. So that's 12 minus 27. That is definitely going to be negative. I really don't care about the value, just the fact that it is negative, meaning the function is negative from 2 all the way to the right forever and ever and ever. And I really shouldn't have to think about this too much. Negative 3, right? Negative 3 squared is still positive 9, so I'm going to get the same result, a 12 minus 27, which is negative as well. So I am saying that my function is negative for x less than negative 2. It is positive between negative 2 and 2, and it is negative to the right of positive 2. I did graph it as with the others, and there it is. Makes sense. My zeros, my critical points, negative 2 right here, positive 2, and you can clearly see the function is negative to the left of 2. It is positive between negative 2 and 2, and then it goes negative again below the x-axis to the right of 2. Now notice, even from left to right, if I were thinking of like walking along this, I am moving upwards, and that upwards is a positive direction. But that's not what we're after. We're after the value of the function. And remember, the value of the function is the y-coordinate. It's all the y-coordinates. All the y-coordinates here are negative because it's below the x-axis. All the y-coordinates here are negative because it's below the x-axis. And all the y-coordinates here are positive because the graph is above the x-axis. All right, so now here, oops, I guess it'd be nice if I had a pen. So this was A, and now we're doing B here. Clearly, my only 0 is going to be 3 because 3 minus 3 is 0, and the only thing squared that is 0 is 0 itself. So my critical point, this is weird, I only have 1, is 3. So where are we? Okay, so I got my sign diagram, and my critical point is 3. So if there's going to be a change in sign, it will occur when x equals 3. Let's choose 0, my fave. So my test point is x equals 0. I'll put the function up here just so I can kind of think about it maybe a little easier. So if x equals 0, I get 0 minus 3 is a negative, but a negative squared is a positive. So this term is positive. This term is negative. A negative times a positive is a negative. So 0 is to the left of 3. So that means everything to the left of 3. The value of the function to the left of 3 is going to be negative. Then I have a test point for x equal to 4. Okay, let's see how that works out. Erase these. So I have 4 minus 3 is a positive 1 times a negative 4. Oh, it's also squared, sorry. I didn't mean to erase that. 4 minus 3 is 1. 1 squared is a positive 1. A negative times a positive is a negative as well. So they're both negative. So the entire function is beneath the x-axis. Let's have a look at that, shall we? So here it is, and looky. We have a quadratic that touches the x-axis, so it is never positive. On both sides, the function is always negative. Okay, so it does make sense looking at our sign diagram. All right, one more example. Draw a sign diagram for this function. Okay, so we need to find its zeros. Now this is a rational function. So a rational function is where we have expressions in the numerator and the denominator with at least one of them containing a variable. Okay. Well, in order for a fraction to be equal to 0, the numerator must be equal to 0. Okay. So I can either think of it that way and know that my 0 will be at x equals 1. Or if you want to solve the equation, it's really you have x minus 1 over 2x plus 1 equal to 0. To clear this, you're going to multiply both sides. Oops, I ran out of room here. 2x plus 1. And that cancels there, and you multiply this side by 2x plus 1. And 0 times anything is 0. So you end up with x minus 1 equals 0 anyway. So you might as well just look at the numerator. Now, I do have a spot where this could be undefined. The function could be undefined because I have a denominator. And that would be undefined when the denominator is equal to 0. Because if the denominator is 0, there's an attempt to divide by 0, which we know we cannot do. Solving for this, I get x equal to negative 1/2, so I have my two critical points. One of them is a 0, which is 1, and one of them is where the function is undefined. So let's draw our nifty sign diagram, see how this is going to work out. I've got 1 right here, and I've got negative 1/2. And I'm going to think about x minus 1 over 2x plus 1 for my test points. And so my first test point I'm going to let be x equals 0. Okay, and if I let x equals 0, sometimes I like to do it like this if it's an easy number. I think to myself, well, I have something divided by something else, and I do not care about the value. I just care about whether it's positive or negative because I'm doing a sign diagram. So my test point is x equals 0. If I have 0 minus 1, that is a negative in the numerator. And if I have 2 times 0 is 0 plus 1, that is a positive in the denominator. That indicates that the function will be negative on this interval. This is where 0 resides, between negative 1/2 and 1. And when I used that test point, it was negative. Okay. What about a test point of x equals 2? That's over here to the right of 1. So I'll use the same strategy. 2 minus 1 is positive. And 2 times 2 plus 1 is positive, and a positive over a positive is a positive. Okay? And then my last test point, less than negative 1/2, might as well use x equal to negative 1. So again, I'm just going to test her out here. And x minus 1. If I have negative 1 minus 1, that is going to be negative. And then if I have 2 times negative 1, that's negative 2 and a positive 1. That's a negative and another negative, and a negative over a negative is a positive. So to the left of negative 1/2, I have a positive. And so let's take a look at the graph. That's the sign diagram. That's all they asked for, but I always like to show you the graph. Okay, and I've graphed x minus 1 over 2x plus 1. And let's go left to right here. We had an asymptote, if you want to think of it as an asymptote, that was at x equals negative 1/2, or if you want to see the asymptote. And to the left of the asymptote, the function you can see is always above the x-axis, so it's positive, as we have it indicated here. And then between negative 1/2 and 1, you see the function, the part of the function that is below the x-axis, indicating it's negative. And then to the right of 1, it's going up and up and up and up and up. It's above the x-axis, so it is positive. All right, I hope you enjoyed it. That is it. That's all the time we need. And I am out!